Welcome to qnawire.
Over here, we're given three different chemical reactions, and we're told that we need to consider an activity series. In this case, since the activity series is not given to us, what I'm going to employ is the redox potentials, which is most likely what is going to be useful for us in order to solve this problem. So first of all, on the list that I have over here, there's an extra missing reaction that is going to be useful for us, which is going to be for cobalt solid, and the potential for this is going to be of minus 0.28 electron volts. So remember, for a redox reaction to be spontaneous, the potential of the reaction needs to be larger than zero. That means that the potential for the reaction corresponds to the sum of the potential of the reduction reaction plus the potential of the oxidation reaction. So for the first reaction that we're going to have at hand, reaction A, we're going to have that cobalt as a solid and aluminum 3 plus in aqueous medium are going to be the species that we're going to have in solution. What we want to happen is that cobalt is going to oxidize into cobalt 2 plus, and aluminum is going to reduce into aluminum 0 as a solid. So the number of electrons here, it really doesn't matter that much. Plus 2 electrons, and over here 3 electrons, and we really don't need to balance out the reactions. In this case, we just need to assess if there's going to be a reaction or not. So over here, the first potential corresponding to this part would be of minus 0.28 electron volts, and then the oxidation corresponds to the negative of the reaction that we have here. So it would be of 1.66 electron volts, the inverse reaction over here, as you can see. So adding up both of these potential, we're going to have a potential that is going to be positive, so the reaction is going to occur. And now we can proceed to balance out the reaction. To balance out this reaction, we need to multiply the first equation by 3 and the second one by 2. The potential for this reaction would be 1.66 minus 0.28, which gives us a potential of reaction equal to 1.38. And the balanced reaction would be with the ionic forms: 3 of cobalt as a solid plus 2 aluminum 3 plus is going to produce 3 cobalt 2 plus 2 aluminum as a solid. And the number of electrons that is going to be exchanged is going to be 6 electrons on each side of the equation. But as you can see, both of them are going to cancel out. So this would be the reaction that occurred on part A. Now for B, we're going to have, let me erase the procedure for A, and we are going to proceed with B, since we have already that part of the list. For B, now the half reactions are going to be going from zinc as a solid into zinc 2 plus, and going from silver in aqueous media into silver 0 as a solid. So in this case, what we can see on the potentials is that the reduction reaction of silver, in this case we can look at the species in aqueous media, which corresponds to this part over here, is going to have a potential of 0.80 electron volts. And the oxidation reaction of zinc, we need to look up zinc solid on the right hand side, which is over here, corresponds to a potential of plus 0.76 electron volts. So as you can see, this reaction is going to occur. This is going to be a positive potential. So the overall potential would be of 1.56 electron volts. And to balance out this reaction, we are going to have that, again, multiplying by the number of electrons of the other reaction, this one by 1, this other one by a 2. Also, unfortunately here we're not given if this reaction occurs like in a solid state. For example, in the case that here it specifies that it is a solid, then we would need to employ the potential corresponding to silver chloride as a solid. In this case, I'm assuming that this goes into solution and produces silver plus and Cl minus ions. Okay, so the overall reaction then is going to be zinc 2 plus, sorry, zinc 0 as a solid plus 2 of silver plus is going to produce 2 of silver 0 as a solid plus zinc 2 plus. And the number of electrons that is going to be exchanged is 2 electrons on each side over here. And the chlorine ions are going to appear just as spectating ions on this reaction. So the second one is also going to occur. And for the last one, for part C, what we will get is sodium 0 that should go into sodium plus 1 electron, and lead 2 plus that should go into lead 0 as a solid, and this requires 2 electrons for the reduction. So the reduction potential for lead 2 plus is going to be minus 0.13 electron volts, and the oxidation of sodium corresponds to plus 2.71, the inverse of the redox reaction. So adding both of these quantities up, we're going to get 2.71 minus 0.13 gives us a easier, the potential of the reaction would be 2.58 electron volts. So with this, the reaction is going to occur, and again, we need to balance it out. It would be 2 of sodium 0 plus lead 2 plus, that is going to react to produce 2 of sodium plus lead 0 as a solid. And with that, it would be all. Thank you very much and have a good one.